This is Aribasha Shamoon, an undergraduate student from Department of Computer Engineering, third year, and this is my presentation for selected topics in computer application. So the research paper that I have chosen has title a syntactic classification based on web page ranking algorithm. So about the introduction. The main job of search engine is to give back the results for input query, and in order for a search engine to be efficient, it is crucial that the search results should be relevant to the query. Now here comes in play the web page ranking algorithms. Search engine consists of four discrete software components: crawler, which downloads the web pages, or we also name it as web spider. Second is indexer, which dissects the web pages. Third is the database, where downloaded and processed pages are stored. And fourth is the search engine result engine, which takes the search results out of the database. Now page ranking algorithms. Page ranking algorithms play their role at the last component, which is the search engine result engine. Exactly what information the user wants is unpredictable. So the web page ranking algorithms are designed to anticipate the user's requirements from various static and dynamic features. There are many existing search engines with many existing web page algorithms, page ranking algorithms. The existing search engines sometimes give unsatisfactory search results. This is because of the lack of categorization of search results. This algorithm, which is proposed in this paper, takes the preference of the user about the search result and rank the pages accordingly, which makes the result more useful and accurate to the user. This algorithm has a interface through a text box with some option buttons to fine-tune the options while sending the query to the search engine. Now let's talk about the existing page rank algorithm before we move forward to the proposed solution. So some of the most common are Kleinberg's hits algorithm, which is hits for hyperlink induced topic search. It is purely a link structure based computation which ignores the textual context. Similarly is the Brin page rank algorithm, the infamous Google search engine backbone. It also has similar functionality. It high ranks if the sum of the pages of its backlinks is high. One another of the very common is Clever project. Clever project, it mainly emphasizes on the enhancement to hits algorithm, hypertext classification, focused crawling, mining communities, modeling the web as a graph. This system ranks the pages primarily by measuring links between them. Then there's a companions algorithm. Companion algorithms introduces a new concept which is exploiting not only links but also their order on the page. There are some of them are uses more parameters such as damping factors or confidence of a page with respect to a particular topic. But most of these web page ranking algorithms does not take any extra information from surfer for giving an accurate ranking. Now about the drawback of the existing algorithm. What is lacking in all these existing search engine is a proper classification of search pages and ranking according to that. Secondly, a lot of work has been done on web classification, but they are based on semantics of the context of pages. But the existing classifiers are like education, art, humanity, and entertainment, etc. This type of classification is of not much help to web page ranking for most of the search engines. For example, if a search topic like human computer action interaction is given, it is easy to guess that education related pages are wanted. So there's no need to classify in educational and entertainment and so forth. Now about the approach which is proposed in this paper. So the approach taken in this paper is to make classification of web pages based on only syntax of the page and change the search engine interface to take the proper class of a page along with query topic. And classification will be like index page, home page, articles, definition, advertisement pages, etc. This type of classification is independent to the semantics of the content of a page. So it can provide useful information for ranking a page according to users' demand. For example, if a search topic is given like antivirus software and given category of page is home page, then the home pages of different antivirus companies will get higher rank. Now let's say if for the same query, which is antivirus software, the category given is article, then the pages giving general description of antivirus software will get higher rank, like the Wikipedias or the article related to the antivirus software. Now again, if with the same query the category is index, then a page having large number of links to different antivirus software vendors will get a higher rank. For a single query, and a particular page gets a different ranking based on the user's demand, what the surfer wants, which was not possible in existing algorithms. Now some of the relevant terms in these algorithms. The first is relevance weight. Relevance weight, it measures the relevance of a page with respect to a query topic, the input string. The relevance of a page is gradually increased as more portion of the query topic occurs in the page. As for example, a search string like data mining may be considered. So in this relevance weight, the counting number of occurrence of the query topic or part of the query topic within the text of the document is counted. The term frequency matrix provides the useful information for calculating the relevance weight for whole search string or the partial keywords of the search string. 3-level scoring method is used to find the page relevance weight, and the algorithm used in relevance weight is, so in order to implement the algorithm, first we have to remove the words in the stop list so that they don't get the higher ranking because of the high frequency. After that we have to apply proper stemming, and after the proper stemming, the relevant keywords or terms that are extracted from the search string, then we apply the algorithm on those strings. The occurrence of each keyword and term are found out, and a weightage is given to it as the ratio of its length to the length of the given query topic. So for example, let's take the search string be data mining, and let's say in page A the only word mining appears, and now it may happen that page B appears to be a coal mine, which is not at all related to the search string data mining. So it is inferred that in a web page where the entire search string appears as a whole is more relevant to the search topic than a page where only part of the string appears. And for calculating the 3-level scoring, let's say take a search string data mining. So we can see number of letters here are 11. So weightage of only the keyword mining will be 6 upon 11. 6 because mining has 6 letters. So this comes out to be 0.545. Now let's take weightage of data mining, the whole search string. It's 11 upon 11, which is 1. Now about the implementation of the relevance weight. So this function takes input of the file where the document is stored and the search string s, and it returns the relevance weight. It has a variable keyword set. Keyword set is an array which stores all of the each of the keywords or terms in the search string. Variable cnt, which is count, short for count, which stores the number of keywords in the keyword set. Then occurrence is again an array which stores the frequency of each keyword in the keyword set. Then a loop is run from 1 to count total number of keywords, and occurrence of each substring, which is each keyword in the keyword set, is counted and stored in occurrence array. Then again another loop is run and relevance weight is calculated with the same formula, that length of keyword set, each keyword by length of total search string into number of occurrence. Now hubs and authority weight. So hub and authority weight of a page is calculated in similar fashion as in Head's algorithm. Authority value of a page P is sum of hub scores of all the points that points to page P. This is, and hub value of page P is sum of all the authority scores of all the page that page P points to. This one. Now another important aspect of this approach is link analysis of a page. So hyperlink information of a page are also found to give useful information during syntactic categorization of web pages, like the number of hyperlinks, number of anchor tags, number of anchor text, and position in domain tree with respect to particular page. Anchor text can be used to calculate the weight of links during calculating the hub and authority weights. Now another aspect is type of contents which is present in the page. So the syntactic analysis of the content also gives useful information about the type of a page. For example, let's say if it's an article like a Wikipedia, then it has more text and more hyperlinks and less images. If it is a advertisement or e-commerce page or similar pages, it will have more images. So there are these type of properties which is counted. Some of them are number of images in a page, text length to number of images proportion, relevance weight of a query string within special tags like heading tag and title tags of the web page. So similarly, and based on these contents of the page, different types of pages is categorized, but we were talking all along about the classification of the web pages. So let's say if a page is an index page, so it will have small number of hyperlinks and have large hub weight because it will be pointing to many other documents. If it is a home page of any website, then it will have large number of hyperlinks pointing to the lower level nodes in the domain tree. Because it is a home page, it will be pointing to other pages of the same website. It will have few images. If it is a portal, it will have large number of hyperlinks pointing to same level, like a AMU controller website or amu.ac.in. If it is an article, then it will have large document length like a Wikipedia and have high relevance weight. If it is an advertisement page, it will have large number of images and thumbnails. If it is a research paper, then it will have large length of the whole document will be very large, and its format will be mostly like .pdf or .ps. If it's a download, it will have .zip or .exe or similar. Now about the implementation of the algorithm. So for algorithm, first we have to select the attributes based on user demand. Based on the user's demand, the algorithm chooses a set of properties of a web page, like we discussed here. And then among these properties, some properties are chosen irrespective of the user's demand. Some of the which is the mandatory properties, like relevance weight, hub weight, and authority weight, and other attributes are chosen based on user's demand to provide an accurate ranking, like number of hyperlinks, number of images. Second thing, and then after the attributes are selected, the measure of attributes for each web pages is measured, and then they are ranked. The rank is calculated by taking the weighted average of the measured values. The weight assigned to each attribute is based on user's demand. Now this algorithm provides flexibility in two grounds. First, in selection of properties. As for example, when the user's demand is index page, the number of hyperlinks of page will be measured, whereas let's say number of images or text to image proportion will not be measured. Now in determining weight of selected properties, the selected attributes get different weights for difference in user demand. As for example, for article type of pages, relevance weight and authority weight will get highest weightage, whereas for advertisement type of pages, number of thumbnails and hub weight will get higher weightage. So these varying selection properties and their corresponding weightage, the algorithm provides more flexibility to the user and also gives more accurate result. Now the working part. So for the working of this web page ranking algorithm, and to test the algorithm, this algorithm was run on the top 30 pages downloaded using Google search engine with the search topic human computer interaction. Now if you can see the interface, it has input box for the search string, and it has some options, like if you want a home page or want index or an article, downloads, definition, tutorials, default for no choice. So when the user selects the type of the page as index, the following 3 pages were the top 3 ranked using this proposed algorithm. And in this algorithm we can see the top 2 are literally index pages, while the third one is the home page of Center for HCL Design City, University of London. This page also contains higher number of hyperlinks, which is also kind of like an index page. Now again with the same search string, the type of page is given as article. Then these were the top 3 page ranks. Here also the first 2 sites are text intensive articles. Now another experiment was done by the authors of this paper, where several web pages were downloaded and classified according to the proposed properties from an existing search engine and ranked according to this algorithm. About 50 pages were downloaded from Google search engine, and the pages were clustered according to following properties: relevance of weight, relevance of image, number of images, number of links, number of self links, number of links to same level of pages in the domain tree, number of links to the lower level pages in domain tree, and document length. And for clustering purpose, fuzzy C means algorithm was used. So this is the result that they obtained. So as you can see in this table, cluster 1 and cluster 4 stands for pages with high relevance weight. They have a relatively very high relevance weight to the other two. Cluster 2 stands for pages with large number of hyperlinks and of short length. Cluster 2 has large number of hyperlinks, it is the highest, and the length, document length, is the lowest among the all 4. The difference between same level and lower level links were greater for cluster 1 and 4 relative to other two. Here the difference is about twice the this amount. Here the difference is about twice. the same difference, but here the difference is very small. So it can be inferred that web pages which belongs to cluster 1 and cluster 4 offer some type of services or portal type of web page. Now they also used a NeoNet Pro, which is a software used for pattern recognition, data mining, modeling and prediction using neural networks for classification. And this is the result they obtained with the simulated software. Since the classification was carried only using 7 properties, these 7 properties, and the data set was also not very large, they said they use only 50 web pages. Still, the result of the fuzzy clustering algorithm had less than 20% RMS error, which is a huge achievement, because classification confirms the existence of syntactic classification of web pages. So you can see the blue ones were the actual that they received, and red was the predicted, the theoretical value. So only 20% was the error. Now coming to conclusion. So this paper discusses a web page ranking algorithm which consolidates web page classification with web page ranking to offer flexibility to the user as well as to produce more accurate search results. The classification is then based on several properties of web pages which are not dependent only on meaning of its content and forward backlinks like other page ranking algorithms. So this was about my presentation. Thank you.